Hello again, this is Tim Lloyd from gmat.cz, part of Gain Access. If you subscribe to our YouTube channel, you can watch this and any other videos we've got for free there. And of course, every time we upload a new one, you'll automatically receive it and be informed. So this question is another higher advanced question from Sandeep Gupta. It's not super difficult, I wouldn't put it above 700, but for sure it's advanced and you need to know a certain formula to calculate the sum of the internal angles of a polygon. This again is a data sufficiency question, and again, as in the other videos, you shouldn't be watching these advanced videos unless you're absolutely comfortable with the AD or BCE decision process or a similar process that enables you not to have to read the answer choices for data sufficiency every time you see it in an exam. So as you can see, this is a yes/no question. Maybe pause the video and give it a try yourself if you'd like to. The way we're going to do it is we're very simply going to consider the variable. In this case, there's only one from the question stem, which is n, where n is the number of sides of the polygon. And then of course we're going to look at each statement and decide how does the additional information improve the limits of what the variable n can be. Now to begin with, we know that n is less than 9, therefore because n has to be an integer and because a triangle is considered the smallest polygon with the least number of sides, therefore n can be considered to be in the range of 3 to 8 inclusive. So n is less than or equal to 8 and greater than or equal to 3. That's all the analysis we can really do from this question stem, but it's a vital step. Of course, as we teach all our students, you do need to respect the question stem, isolate the variables, isolate the limits of those variables, okay, and then move on. So now we'll look at the first clue by itself, of course. So the first statement tells us something in terms of the sum of the interior angles, and as pointed out earlier, n minus 2, where n is the number of sides, multiplied by 180 gives us the sum. So we assume that you know that, and then of course it has to be divisible by 16 as given in the actual first statement. So the first thing we do, and as we tell our students, look, if you're not sure what to do, just break numbers down into their prime factors, because very often number theory, number properties is going to be involved as a topic in other types of questions such as geometry. So here we know that inside 180 we have the prime factors through prime factorization of 2 to the power 2 times 3 to the power 3, in other words 4 times 9 times 5. Okay, so if you need help with that, feel free to watch one of our other videos, check out the theory, but we assume that you're confident with that step. 16 is 2 to the power 4. Now, okay, so we know now what has to be inside n minus 2 times 180. The trap here and the mistake is if you consider that this tells you something about n directly. It doesn't. It tells you something about n minus 2. So we know that n minus 2 needs to fill in the missing 2 to the power 2 because 180 is not divisible by 16. Okay, we need at least 180 times 4. We need the 2 to the power 2 at least. So the easiest way to consider that is to consider numbers which will give us that. So 4 is a number that will give us that. 8 is a number that will give us that. In other words, any multiple of 4 will give us the 2 to the power 2 that's missing. So if you're not sure about what we just did there, pause the video, consider what prime factors we have in 180, and then consider what prime factors we have in the 16. Realize that divisibility means that the extra missing prime factors, in this case at least 2 to the power 2, must be inside the n minus 2 because they're not contained in the 180, and that is the actual core to this particular question, which makes it advanced. So I've chosen n minus 2 to be 4, n minus 2 to be 8, and n minus 2 to be 12, as you see, but the only possibility is the first one, because that would make, if n minus 2 is 4, n would be 6. 6 falls between the range of possible values of n. However, n minus 2 being 8 immediately is too large, n cannot be 10. So You of course can try n minus 2 equals 0, but not a good idea. So we're in a situation in which we now know the value of n according to the information from the question stem and the additional information, in other words, the additional limits from the first statement. Answer choices A or D are the only possibility. The direction, therefore, is you cancel B, C, E as potential answer choices and you move on to statement 2. Statement 2 tells us some information in a very similar way to the first statement. Again, it's about divisibility, the divisibility of n minus 2 times 180, this time with regard to 15. We know 180 breaks down in prime factors terms to 2 to the power 2, 3 raised 2 and 5. So all we do now is a similar process as we did for the first statement. We break 15 down, this time into its prime factors. And of course 15 contains 3 and 5. 3 and 5 are automatically already contained within the 180. So you don't need to go any further here, because 180 is divisible by 15. We have no information at all about the value of n other than that, as we knew from the question stem, that n is between 3 and 8 inclusive. So we would need more information to increase the limits to then be able to say n minus 2 is one particular value, or n in this case is one particular value. Job done. We can now cancel D as an option and choose answer choice A. So this wasn't a super difficult question. It just requires a couple of pieces of knowledge with regard to methodology of prime factorization and of course divisibility confidence. You would immediately say, well, hold on, I know 180 is divisible by 30 or 60, however it works in your mind, and therefore it must also be divisible by 15. Thank you very much. I hope you enjoyed this video. If you've got any questions, feel free to click the link, contact us on any of our social media, and we'll be delighted to get back in touch with you. See you soon in one of our upcoming videos. And of course, thank you again to Sandeep Gupta. This is Tim Lloyd for GMAT.cz, part of Gain Access. Goodbye.